So just so you know, for the electron transport chain, I will try to find a YouTube video that actually shows you how that works. Okay. Just remember that our high energy electrons are batteries and getting passed from protein to protein, charging them up so that they can pump the hydrogens to the other side of the membrane. Okay. But I'll find something. All right. So let's talk fermentation. So again, going back, fermentation is very different than the other two because it's not as many steps. So in fermentation, you only get a small amount of ATP, only 2 ATP per glucose instead of 36 to 38. Okay. It permits the production of energy without oxygen or the electron transport chain. So it does have the benefit of I don't really need an acceptor at the end. Okay. It produces the end products like ethanol or carbon dioxide, acetone, lactic acid, or acetic acid. So, depending on the bacteria that's using it, or I shouldn't say bacteria, the microbe that's using it, you may end up with ethanol, drinking alcohol, carbon dioxide, acetone, lactic acid, acetic acid. So, the pyruvic acid from the glycolysis can itself become an electron acceptor. Pyruvic acid can also be enzymatically altered and then serve as that electron acceptor. The NADs are recycled to re-enter glycolysis. So literally, I can go back to glycolysis. Remember my two NADs that I needed to pick up here? Okay. And put them back into that step. I can basically take the hydrogen off, and then this NAD is free to go back to the beginning. Okay. The organic molecules that become reduced in their role as an electron acceptor are extremely varied. Look at this list. And they can be, again, ethanol, carbon dioxide, acetone, propionic acid, butanol. There's a long list of what these things can basically get converted into. The ultimate, I guess, thing to think about is in fermentation, I still have to have a way to kind of get back to the beginning because I don't have a choice. So that NAD actually getting rid of the hydrogen it's carrying, the taxicab dropping off that hydrogen it's carrying to make ethyl alcohol or lactic acid allows that to go back into my glycolysis cycle. Okay. So, anabolism. Remember, I said metabolism is breaking down and building, anabolism is the building half, catabolism is the breakdown. So, macromolecules, big molecules, are needed to perform functions in the cell. You have to build them. And that process of taking component parts and building something more complex is the process of anabolism. Glucose is needed to make complex carbohydrates for your cell walls. Are great. Peptidoglycan, there we go. Sorry. It's also needed to make nucleic acids, to make the capsules. Glucose is one of those simple carbohydrates that we need to make the more complex ones that help us make other things. Proteins are needed for enzymes, for the cell membrane, for the cell wall, even other cell structures like channels. They are proteins. So I have to be able to make those basically from scratch so that I have those component parts that I need. You can't run your car if you don't have spark plugs. You can't run your car if you don't have a fan belt. You can't run your car if you don't have tires. You can't run your car if you don't have an engine. Same type of thing. Proteins are one of those things that you have to be able to build. Okay. Nucleic acids are the genetic material. It's the genetic code. It's the instruction manual. And again, If I'm going to divide through binary fission to make clones, I have to be able to build nucleic acids. This allows me to clone myself through binary fission, and both of us have the same genetic information. Okay. Um, the macromolecules listed above are constantly being synthesized, they're constantly being made and basically incorporated or put into other things or used in the cell, so that um, my cell lives, my cell functions. Especially when the cell is ready to divide, all of these things need to be there. Carbohydrates, like I said, are part of the cell wall. They're part of nucleic acids. They're part of the capsules. Proteins are part of the cell membrane, the cell wall. Nucleic acids. If you divide a cell and it doesn't have its own genetic material, it was pointless to divide the cell because it has no instruction manual. It's basically just a bubble. Okay? If I am getting ready to go through, where did it go? Oh, binary fission was in the last chapter. If I am getting ready to go through that process of binary fission, I have to make new ribosomes. I have to make new genetic material. I have to make more cell walls so that when we divide, we are the same size as when I started as a baby cell. If I'm a bacteria, I also have to make cell wall for both of those clones. So through the process of anabolism building, I make those components. Yep. So that is chapter 7. If you have any questions, just like always, you can text me or hop on Life Size.